Okay. So we're still using the chain rule notes from before. We're just going to go ahead and work through the last few examples that I had up there. And I'm just going to call this double chain rule because that's what it is. So the first example was y equals 1 plus cosine of 2x all squared. Okay, so we can write it out formally using the f and the g, but we'll have to have an h function as well. Or we could just do it like the shortened way that I like to do. We can go ahead and do it both just so you guys see how it works. So using the f and the g, I know my outside function is the parentheses raised to the second power, which means the derivative of that is going to be 2 times whatever's inside the parentheses, and then raised to the first power, right? Because I decrease that exponent by 1. My g function is what's inside the parentheses, so 1 plus cosine of 2x, or cosine of what's in the parentheses. There we go. We'll do it that way. And then the derivative of that is the derivative of 1, which is 0, plus the derivative of cosine, which is negative sine of whatever's in the parentheses. And then I also have an h function because I have another set of parentheses that has a function inside of it. So pretty much every time there's a parentheses within a parentheses, it indicates another function that was being plugged in. I just used blue. So let's do red. So then I also have my h function, which is my inside function, which here is 2x. And then the derivative of that is just 2. So then this is how we are going to do the chain rule for this. We're going to do that my overall derivative is equal to the derivative of the outside times the original inside times the derivative of the next outside function with the original inside times the derivative of the inside. So it's kind of like your Russian nesting dolls. Every time we take away one of the outside dolls or functions, there's another new outside one. And that's what we constantly are taking the derivative of, leaving everything else inside the same. So from here, I just go ahead and fill in all of these derivatives and original functions that I have above. So y prime equals the derivative of my outside was 2 times whatever's on the inside. So then I plug in the inside, which was 1 plus cosine 2x, times the derivative of my g function, which became negative sine over whatever was in the parentheses, times the derivative of what was in the parentheses. And then from here, we would just simplify. Since everything is being multiplied, we can put our stragglers together. So I'm going to put this 2 and this 2 together, and then I'm going to bring the negative sign to the front, which means I have y prime equals negative 4 sine of 2x times 1 plus cosine of 2x. And then I can distribute this to each of those values, which leaves me with y prime equals negative 4 sine of 2x minus 4 sine of 2x cosine of 2x. And then I'm done. Questions, concerns, or issues with that one? Okay, next example. This one isn't really chain rule within chain rule, but it is product rule and chain rule together. So it's still a fun one. Okay. So on this one, I'm going to treat it like a product rule just because, you know, that's easy to do. My first function is the secant of 2x, and my second function is the tangent of 2x. Whenever I take the derivative of each of these, I'm going to have to use chain rule on both. Okay, so just so you are aware. We're going to go ahead and do it the way that isn't written out like the previous example. Excuse me, sorry. So when I use product rule, I'm going to take the derivative of that first function first. That first function will be a chain rule problem. Okay, so I need to take the derivative of secant first, leaving everything inside the same, and then multiply that answer by the derivative of the inside. So what is the derivative of secant?
Secant x, tangent x.
Right. So now this is going to be secant parentheses, tangent parentheses, where inside the parentheses I have 2x, and then times the derivative of that 2x, which is 2. So that's the derivative of my first function. And then that's going to be times the original second function. And then plus my original first function secant of x, or secant of 2x, sorry, times the derivative of that second function tangent of 2x. So again, this one's chain rule. I need to take the derivative of tangent first. What is the derivative of tangent? Ethan cannot answer.
Secant squared.
Secant squared. And it's going to be secant squared of 2x, and then times the derivative of 2x, which is 2. So now what I get to do is I get to put all of this together, which I know sounds like so much fun. So what I'm going to do is I'm going to take the 2 and the tangent. Actually, I'll just do the tangent first. I'm going to take the 2 and put it out front, and I'm going to take the tangent, and I'm going to multiply it into this. So when I do, I get y equals 2 times secant of 2x times tangent squared of 2x, because I have a tangent 2x times a tangent 2x. And then plus, I'm going to go ahead and put this right side together. The 2 is going to come out front. And then the secant 2x times the secant squared 2x becomes secant cubed 2x. And then that's where we're going to stop. Questions, concerns, or issues with that one? Anybody super like not following what's going on?
That one wasn't a double chain rule, was it?
No, I said this one was a product rule that had chain rule on both sides,
Okay.
not chain rule within chain rule. So let's go ahead and do another one. Okay, so for this one, I would like to do 9 tangent of x over 3. This one is also not a chain rule within a chain rule. I don't think we need to do a ton of practices of those, though we can if you would like. But this is another one that could confuse people. So as I'm looking at this, my goal is to make this as simple as possible. So I need to do something with this x over 3. This, remember, would be the same as just having the fraction 1/3 times x, which seems a lot easier to work with than x over 3. So then from here, I would just be able to use chain rule to take the derivative. I know the derivative of tangent is secant squared. The 9 is a constant, so it's just going to stay out front. So I have 9 times secant squared of 1/3 x. And then times the derivative of 1/3 x, which is just 1/3. I can put my stragglers together, so the 1/3 and the 9 come together to get 3 secant squared of 1/3 x. Questions, concerns, or issues with that one? We're going to do one more chain rule within a chain rule, and then I'm going to let you work on the homework for today. Okay, so let's do another one. Oh my gosh. There. We start on the outside first. So my outside function is going to be sine of the parentheses. The derivative of sine is cosine. So now I have y prime equals cosine of everything inside that parentheses times the derivative of the inside function. My inside function is 4x squared minus 3 cosine of parentheses. So then the derivative of that is going to be 8x plus 3 sine of whatever is in that parentheses. It became plus because the derivative of cosine is negative sine. So minus a negative became a positive. And then times the derivative of the very inside of the function. And the derivative of 4x squared is 8x. So from here, I wouldn't necessarily expect you to simplify all the way just because that would be a lot to write, though you absolutely could. But I would expect you to simplify those two together. So multiply the 8x into both of those, and I get y prime equals, we'll leave the first function the same for now. And then 8x and 8x become 64x squared plus 24x sine 4x squared. And then if you wanted to continue from here, we would do this entire function times each of those inside of there. I won't make you write that, but that would be the next step. So you'd have 64x squared cosine of all of this plus 24x sine of 4x squared times cosine of all of that. This would be an acceptable simplified spot to stop though. Any crazy questions, concerns, or issues that you have? Okay, your homework is on Canvas. I'm absolutely okay if you guys want to stay on here and work together, or I can put you into break-off groups so that you can work together with like 1 or 2 people to do this, or you can work on it on your own. Either way, I will stay on here for the rest of class. You just need to let me know how you want to work on this.
I think I'd like to just like sit in the main call, and if I have questions, I'll ask.
Perfect. Then I will mute my mic and my video, and then I will stay on here for all of class. I also wanted to let you guys know, because I can't remember if I mentioned it or not, that as long as we stay virtual, I'm going to be giving participation points just for showing up to class and staying for the lesson. Just trying to get kids to log on more. This class isn't so bad, but my other classes have really bad attendance. So every day that you're on, you'll get 2 points. If you log on and leave right away, you'll get no points for that day. Or if you don't show up at all, you won't get any points either. Okay, so you guys pretty much show up every day. I'm not too worried about it. But if you are on every day and you participate, then you will get the participation points. Okay, I'm gonna go ahead and mute my screen and my mic, and then if you have any questions, just let me know.